Hello, thank you for joining me. So in this video I'd like to show you how to put together a spring, and the spring would represent a terminal on top of the battery. And the spring is also dependent upon a helix for its path, which is dependent upon a circle that helps define that helix. So let's take a look at what we did, or what we talked about a little bit in the previous film. We have a sweep. The sweep is based on a path and a profile. Path being a helix, and the helix is based on that circle. So the first thing we need to do is put in a circle. Click on that surface, go to circle, draw that guy out, go to dimension, smart dimension, let's put a half-inch dimension on that. Bang, we're all done, green check mark, we're ready to go. And go to rebuild. So now we have an embedded sketch that's going to help define our helix. Let's put in that helix. Helix is a feature. Even though it comes out as a sketch, it's still considered a feature because it's 3D. It's a dimensionless 3D feature, but it does occupy volume in a way. So it is a feature. So we're going to go down to curves on our feature portion of our command manager, and we're going to choose helix and spiral. It's asking for a plane in order to sketch on it. If we didn't do any sketching yet, we would pick a plane and then draw a circle in order to define that. But we already have one drawn. We're going to pick that guy, and we're going to pick our options. We talked about options a little bit in the previous film, so we're not going to go over that. But what we would like to do, and as part of this requirement of this problem, is we have a terminal that's going to be 60 thousandths of an inch high, or 0.6 inches high, and it's going to have a draft angle of 5 degrees. So we're going to incorporate that. What becomes a variable here, and what's going to be your choice here, is going to be the pitch or the revolution in order to make your spring look right. So we do want height, so we have two choices here. We have height and revolution, and height and pitch. Pitch is a little bit harder to define, so I'm going to go to height and revolution. So our height is going to be 0.6 inches. Revolutions, let's just type in 3 and see what that looks like. Start angle, we can make a start angle in a manner we see fit. One thing to consider here, if you do have a feature on top of your battery, like maybe a clip that connects to the internal mechanisms or internal parts of the battery, in order to make that terminal complete, you might want to turn this around and make changes to that. So if we go to the spin box, or go to the up arrows down here, we can change it by 1 degree at each time, so you can actually see it moving around. And if we were to make that maybe 270 degrees, you can see it actually moves it quite a ways from that point over here to over here. Another thing to take a look at, we can make the spring clockwise or counterclockwise from its origin, if desired, just by going on to that arrow in here. And we're not going to play around with any of the variable pitch settings here, so we're going to stick with that. 0.6 of an inch, 3 revolutions, 270 degrees for our start angle, and we want to have a taper on that of 5 degrees. So if you don't have that, go ahead and do that, and go to the green check mark, and now we have our helix. Our helix comes out blue. I think it's blue because it considers itself not being fully defined, because there is some flexibility with it in regards to some of the settings that we saw. But it is fully defined to the circle, which is fully defined, to the model itself. So I wouldn't worry about the blue. I've never seen it turn black. I don't think we can fully define it from this point. But we are going to be using that now as our path for our sweep. Next thing we need to do is we need to put in some reference geometry. We're going to put in a plane. The two references for a plane, one of them is going to be the helix, or the curve, that's going to be associated with that. Our second reference is going to be the endpoint of that helix here. And from this plane, we're going to be drawing our profile. So we want to make sure it's perpendicular on the edge of our helix. At that point, you want a coincident relationship in here. You want all these settings in here. And what that does is it provides us a plane that's perpendicular to this line as it comes to that point down here. And now we can draw on that. Sketch on that, actually. So our plane 3, we're going to call that our helix plane. Oh man, I just can't spell today. I can never spell. Oh man, I still can't spell. Helix. Alright, helix plane. And from there we're going to sketch. So we're going to click on that plane, go to sketch. Let's go normal too. And now we're going to draw a circle that's going to be 50 thousandths of an inch in diameter. So 0.05. Now, this next step, we're going to take the midpoint of that circle and our helix, and we're going to find a relationship between these two. Let's try that again. Still in smart dimension, sorry about that. So the center of that circle, the helix, and we're going to find a relationship. The only relationship it gives us is Pierce. We could conceivably pick the center of that circle and the projected origin. I don't know if it's going to give us a relationship there, because I don't think the origin necessarily, or maybe just barely, intersects that plane. But they're correct, and the appropriate relationship here is going to be the Pierce relationship. Center of the circle, helix, Pierce. Now if you think about this plane, the reason why I stretch it out, I didn't really stretch it out all the way, but this plane actually intersects that helix, and if we have 3 revolutions of this thing, it actually intersects it in 6 different places. This could be a place, could be a place over here, because that helix intersects the plane in those areas. Could be here, 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 or here. So it looks like it's 7 locations once it gets done making all those revolutions. SolidWorks, with the Pierce relationship here, will choose a position here at its own choosing, at its own convenience. It's usually some place it's going to be close, so it's probably going to be in this area. So if we go to Pierce, it's on the bottom. So at its own choosing, at its own convenience, we're going to stick with that. And we're going to go to rebuild. So remember the sweep. Sweep needs geometry. Actually, it needs 2 independent sketches. One's going to be the path, one's going to be the profile. And from there, we're going to go ahead and choose our elements that we're going to be used for our sweep. So I'm going to call that profile 2, because we're profile 1, because I already have one. Okay, there we go. Features. Sweep boss base. For profile, we can click it over here. Our path. Click in the helix. Bang. Puts it up there. And there's our helix. Our helix now should be, if we wanted to do that, it's a separate feature. Let's go back and edit our options here. Let's not merge the results. And if you do that, if you go to the green check mark, we now have a separate body up here. We're going to call that terminal. And now we can assign different properties to that terminal. So go to terminal, go to our display pane over here, and with that terminal we're going to apply appearance. And I chose copper last time, so if I go down here to copper, double click on that, it's going to apply that appearance to that spring. Hide our plane. Now we're as right as rain. If you don't like the way that looks, of course you can go back in and mess with some of the settings in regard to the helix itself and the sweep if you wanted to do that. But typically the sweep is driven by the profile and the path. And if you want to change any of these settings, perhaps maybe 5 revolutions instead of the 3, you could easily do that by going back into the helix and making those changes. So that's what I wanted to show you. Good luck with this, and by the way, this will be an element, an extra credit element to our in-class evaluation coming up the first class of next week.